Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here we are going to discuss it is about the halogens as well as about the noble gases. So, the halogens these are basically the group 7A elements, and these elements are called as halogens. The word halo is means the salt, and the gens mean the forming. So these are basically salt forming elements when they come in contact with the metals. On the other hand, there we have noble gases. Noble gases are from the group 8A elements. These noble gases are highly inert gases. Now, why they are called as inert as well as noble gases? Because they do not react with any other substance. They do not react or they do not participate in any type of chemical reaction. On the other hand, the group 7A elements, these are called as halogens. They contain 7 electrons in their valence shell, and they just required one more electron to complete their octet or to complete their valence shell. And after the formation of or the gaining of this one electron, they acquire the charge -1, and they are changes into the anions. And the halogens contain fluorine, chlorine, bromine, and iodine. So these four elements are making up the group 7A in the periodic table. And the noble gases, here we have helium, neon, argon, krypton, xenon, and radon. These all elements are making up the noble gases as inert gases. Why they are called as group 8 elements? Because they have 8 electrons in their valence shell and they do not require to gain or lose the electrons because their octet is complete. Now this was a simple overview about the group 7 and group 8 elements. After this we have some its physical properties. So the group 7 element contain four elements main: fluorine, chlorine, bromine, and iodine. So here the atomic number of bromine is 9. Its electronic configuration is like helium. If we talk about helium, its electronic configuration is 1s2. And then the valence shell of fluorine is 2s2 2p5. The chlorine, its valence shell is 3s2 3p5. For bromine, its valence shell is 4s2 4p5. And of iodine, its valence shell is 5s2 5p5. So all contain 7 electrons in their valence shell. Physical state or the physical appearance of the fluorine, it is pale yellow gas. Chlorine is also in the form of greenish yellow gas. Bromine, it is a red brown liquid. It is the only non-metal that is present in the liquid state. And iodine, it is present in shiny grayish black solid. If we talk about the ionization energies of these elements, that is given in kilojoules per mole. Fluorine has ionization energy 1681 kilojoule per mole, and that of iodine is 1009. It means when we move from top to bottom in group, the ionization energy is going to be decrease. On the other hand, electron affinity that is given in kilojoule per mole, that of fluorine is -322 and iodine is -295. So there is also a decrease in the electron affinity, like from -322 to 349 and then -325, and at the end we have -295. Electronegative, it is the measure of strength or the ability to attract the shared electron pair towards itself in a chemical bond. The highest electron affinity is of or electronegativity is of fluorine among all the elements in the periodic table, and it decreases when we move down the group in the periodic table. Ionic radius, that is in picometer, fluorine having smallest ionic radius, that is 133 picometer, and that of iodine it has 220 picometer. Then the covalent radius, it also increases down the group 72 to 133 picometer. The melting point is in degrees Celsius. For fluorine, it is minus 219, and for iodine is 114. It increases down the group. The boiling point minus 188 for fluorine, and that last one is 185. It also increases down the group. The density is mass to volume ratio, that is in gram per centimeter cube. Mass to volume ratio, it also increases down the group. Then oxidation state for all these containing the similar, which is minus 1, but the chlorine, bromine and iodine, they may vary from plus 1, plus 3, plus 5 and plus 7. The bond energy is kilojoule per mole when they are having bond like this, fluorine to fluorine, then chlorine to chlorine, bromine to bromine and iodine to iodine. Then what does happen? The fluorine, its bond energy is 154.5, then chlorine 242, bromine is 192.46, and that of iodine is 150.6. It's mean down the group, their bond energy first increases from fluorine to chlorine. There is then decrease from chlorine to bromine and bromine to iodine. So this is a simple description about the properties of the halogens. Then after we have properties of the noble gases. Here the noble gases are basically 6 in number: helium, neon, argon, krypton, xenon and radon. Their atomic number variates from 2, 10, 18, 36, 54 to 86. Electronic configuration of the valence shell is similar, that they contain 8 electrons in their valence shell from 2s2 2p6, 3s2 3p6, 4s2 4p6, 5s2 5p6, and the last one contains 3s2 6s2 and 6p6, 8 electrons in the valence shell. Ionization energy from top to bottom in the group, it decreases. On the other hand, the atomic radius, it is going to be increase when we move from top to bottom in the group. The melting point in degrees Celsius from minus 246 to minus 71. So there is an increase in the melting point, as well as there is also an increase in the boiling point. The boiling point of helium is minus 269 and that of radon is minus 62. Water solubility at 20 degrees Celsius, that helium, neon, argon, krypton, xenon, they all are soluble in water and their solubility is from 13.8 to 110. There is an also increase in the solubility. The last one is heat of vaporization. When they are converted into vapor state, then what amount of heat is evolved? This is called heat of vaporization. So helium has heat of vaporization 0.08, neon 1.77, and that of last radon is 18. So there is an increase in the heat of vaporization when we move from top to bottom in the group. On the other hand, the noble gases are inert in nature. They basically do not react with other substances. So this was all about today's lecture. I hope you guys understand. And if you have any queries, you may ask me about that in the comment section. The next topic that we will discuss, it is the occurrence of halogens. For that time, you guys keep learning and have a good day.